Oh, now we're going.
Hello, Mr. Lopriato here. Video notes on molar mass. All right, so we've been working with the moles. We're going to be converting between mass and moles, and to do that, we need the molar mass. All right, so we're going to look at a couple of elements, then a compound, and where we get the molar mass is our periodic tables. All right, it's right there. So if I want the molar mass of magnesium, I look up Mg on the periodic table, and it's 24.305. Alright, it's the exact same numbers as the average atomic mass, but now the unit, it's grams per mole. Alright, that tells me that 1 mole of magnesium atoms is 24.305 grams, right? 6.022 times 10 to the 23rd atoms of magnesium weighs 24.305. Alright, now let's think about oxygen. We breathe oxygen, we love it, we need it. It's O2. So if I want to find the molar mass of oxygen, I'm going to look up oxygen on the periodic table. Oxygen's 15.999. I'm just going to round it to 16 for right now. But there's 2 of them. So it's got to be 16 plus 16. So the molar mass, when it's written out as O2 with that subscript, we've seen that before, that has a molar mass of 32 grams per mole. All right, we call this a diatomic molecule, a diatomic atom, right? It's 2 atoms, 1 molecule, but it's still a pure element, oxygen. And sulfur, that's another example. S8, all right, so just that's the way sulfur appears in nature. It's 8 atoms of sulfur together, and the molar mass of 1 atom of sulfur is 32.06, and I'm just gonna round that to 32. All right, so 32 grams per mole, but since there's 8 of them, I'm gonna multiply it, and when I do 32 times 8, I believe I get 256. And again, the unit is grams per mole. So if it's a pure element by itself, it's just the number from the periodic table. And if it has a subscript, you just have to multiply it. So now let's look at a bigger formula. NiNO3, we got the parentheses. We've seen this before. We've done questions in the past where we counted the number of atoms. 1 atom of nickel, and then we distribute the 2 atoms of nitrogen, we distribute the 2 to the O3, 2 times 3, 6 atoms of oxygen. So if I'm going to find the molar mass of this compound, I need the molar mass of the nickel, all right, and that's going to be 58.693. There's only 1 of them. I don't have to multiply it by anything. The nitrogen has a molar mass of 14.007. I'm just going to round that to 14. All right, 14, but there's 2 atoms of it. So 14 times 2, 28. And for the oxygen, we've already seen oxygen having a molar mass of 16, but that's per 1 atom. There's 3 atoms in the NO3, and there's 2 NO3s. So 3 times 2. All right, so we're going to do 16 times 6. All right, and 16 times 6 is 96. All right, so these are all grams per mole. We're going to add them up now. So we're going to add 58.693 plus 28 plus 96. All right, and we're going to come up with we're going to get 182.693, and that is grams per mole. So this is how we find the molar mass of either an element, that's easy, or a compound. A little tricky, but really not that bad. All right, we will use these molar masses in questions where we go from mass to moles. So we'll do another video on that. But this is just finding the molar mass of a compound. All right, so good luck.